One question, everybody listen my sound or not? So let me to share the file. Okay, guys, this is the well stimulation webinar about the acidizing. And thanks for introducing me. Yes, I'm Peyman Daneshfar from Iran, and I'm the stimulation and field engineer at the Dana Energy Company in Iran. One of my favorite field that I work on it is acidizing, and I'm especially work on the stimulation vessel deep cleaner in a Persian Gulf. And after loading my file, start the webinar. Yeah, the file is loading. Let us start with some outlines that we want to introduce you or show you some things maybe you learn or maybe you don't want to learn. This is the well stimulation, formation, damage, scheme factor, acidizing type, fracture, acidizing matrix, additive formation, damage, and matrix acidizing job procedure, and yeah, a small maybe explain it about the deep cleaner stimulation with the acidizing job procedure. At first, what is the well stimulation? Well stimulation is a well intervention performed on oil and a gas well to increase production by improving the flow of hydrocarbon from the drainage area into the wellbore. It means that, so when we are a stimulation engineer, we should plan. When the well is not okay, we should plan to cure the well. Okay, let me show you. One of the most popular and the important formula in the oil industry is about the well inflow. You see that? Do you see the well production, formation, permeability, thickness, pressure analysis? If you see here, if we increase the permeability, so lead to increase the production. In the oil industry, we must do our well every time in an improvement or in a normal way. Okay, so every time in a stimulation jobs, we do our jobs to increase the production rate or cure the well to normal in a past, in a before. So if you see that the factor, if the permeability or the thickness increasing, so as you can see in a formula, your production rate will be increased, and decrease in a scheme factor, decrease whenever production decrease when the scheme factor or radius of damage zone increase, so or viscosity increase. So it means that your production rate will decrease. Here we have some stimulation techniques, as the mechanical, as the chemical, biological, or combined mechanical and the chemical and thermal method. But here, just we want to talk about the matrix acidizing, and acidizing may be chemical or combined mechanical and chemical that leads to decrease in a scheme factor And if we decrease in a skin factor, guys, every time remind or remember the mother formula about the well inflow. Okay, when you decrease in a skin factor, absolutely, if other parameter will fix or nothing change, nothing altering, your production rate will increase. So stimulation techniques, when we want to choose a stimulation techniques for cure the well or to remove the damage, we should check all of them. Some parameter as the formation mineral composition, the amount of the damage, or the chemical, about the chemical treatment, or the limitation in our some equipment in jobs, or bottom hole pressure and temperature, and mud filtrate or cement filtrate, or and creating and the compatibility our chemical with well, and the formation properties such as solubility, permeability, and porosity. And one thing I forgot to tell you, some slides title with stars. This is only for your information. Maybe if I have enough time, I talk more about them, but this is only for your formation, and I want to put in my slides, okay? And what is the formation damages? Formation damage is a condition most commonly caused by wellbore fluid used during drilling, completion, and workover. Guys, formation damage is an illness, okay? Formation damage, when the well has a formation damage, it means that a man or a woman got a sickness, okay, got a sick. So the doctor should cure them with some medicine, okay? So, but the formation damage, it can be more or small, but when and each formation damages and need a best cure for it. It means that when you encountered with the scale, you should use the scale inhibitor, no acidizing. Okay, when you see that your radius of damage zone increase and your permeability decrease, so you need to use one of the stimulation techniques as the acidizing. Okay, so here, some formation damages that you can see as a movability change, water like scales and organic deposit, silt and clays, as maybe in a sand production, a sandstone acidizing, and a mixed organic. And you can see that when we have a water block in the oil well or gas well, we can use one of them. In a gas well, we can use acid alcohol, and oil well, some parameter. This is only the chart that you can see. I want to show you and introduce you some formation damages. And the skin factor. The skin factor, formation damages only it's qualified well, okay? But the skin factor is a parameter that introduce the formation damage in a quantity, okay? So let me read the skin factor. Is a dimensionless parameter that quantify the formation damage around the wellbore. The skin factor, when your skin factor is negative, it means that you're well in an improvement. Now you're doing your job as well as you can. But when skin factor is 0, it means that the well is in a normal way. But whenever the skin factor is positive, it means that your well has a formation damages, and it need the doctor, and the doctor should cure it, okay? As you can see here, again, yes, somebody, somebody in a comment zone tell that as like as a Darcy formula, yeah, as like as a Darcy formula. Darcy formula is a modern formula that you can check it in a oil field or oil industry. So again, you see that the production rate and a scheme factor. If our scheme factor increase, lead to our production rate decrease, okay? Every time we should control some parameter, okay, to check our production rate, scheme factor, radius of damage zone, pressure, thickness, and the permeability. As you can remember before, I told before, when permeability or thickness increase lead to production rate increase, but some parameters like as a scheme factor or radius of damage zone increase lead to decreasing in production rate. You can see the schematic of the scheme factor effect on the production, the negative, 0, and a positive. And again, you can see that if the radius of damage zone increase, it means that your permeability in a radius of damage zone decrease, okay? If decrease, it leads to a scheme factor increase, and increasing in a scheme factor again lead to the decreasing in our production rate, okay? What is an acidizing? Acidizing is one of the simulation techniques, okay? It means that acidizing is a technique used in a oil and a gas extraction that is designed to lengthen useful life of oil and a gas well. This procedure commonly enhances production by increasing the effective well radius and decreasing a scheme factor, okay? As you can. What is an acid? Acid is a compound that, when dissolved water, it releases hydrogen. You know, maybe you think with yourself why I want to explain some cheaper slides, you know, or easier slides that you can see, because it you should know about the element or parameter in about the acid in acidizing. Every parameter here, it can help you to design your procedure or your designing acidizing jobs as well as much as you can, okay? So we have some acid, mineral, two famous type of the acid, mineral and organic acid. Mineral as like as a HCl, HF, and organic acid as like as acetic and formic acid. Organic acid react slower than the mineral acid. Remember, organic acid react slower than the mineral acid. Here in acidizing, two type of the acid, two famous type of the acid that every time we use without chemical, if you want to know, HCl and HF. Both of them are important for us, and we can see it in some slides, some next slides. What is the basis and the statistics only for your information? After the webinar, I can give you these slides only for your information, and this is for only read it and know about the bases and salts. Here, we should know about the acid and HCl reaction. You know why? Because we should know about the reaction. Why? Because if we want to calculate the volume of the acid, we need to acidizing the well. We should know about the HCl reaction formula with the formations, as like as the calcium carbonate or dolomite or sandstone. If you see that the product of the HCl acid and the calcium carbonate is calcium chloride and carbon dioxide and water. Okay, this is important for us because we need to use the stoichiometry number in calculating the volume of the formation and volume of the acid. Okay, and another slide is about the HF reaction with the formation with the calcium carbonate, with the sand, with the sodium and bentonite and NaCl. And another one is the reaction of acetic acid, and another one reaction of the formic acid. Okay. Here is a table that show you about the some concentration of the acid, about the hydrochloric, acetic, and formic. We have some concentration that we use it in acidizing. About the HCl acid, 15, 5, 10, or 28 is normal every time we use. Okay, if our concentration of our acid increase, our reaction with the formation will be increased, and the dissolving power absolutely increase. Okay, so and one is a note that you can see, dolomite are similar to limestone with the exception that generally react more slowly with the hydrochloric. Okay, it means that when in a calcium, when you have a formation, carbonate formation, the HCl acid react fast with limestone, but with a dolomite, the reaction rate is slower. Okay. Some treatment we have about in acidizing. Three normal type that we have. One of them is a soaking agitation, or in a normally we tell them acid wash or perforation cleaning. Another one is a fracture acidizing, and another one is a matrix acidizing. In a fracture acidizing, our injection rate above the fracture pressure. But in a matrix acidizing, our injection rate below the fracture pressure. You know, our fracture pressure in acidizing is more important for us than another parameter, because if you exceed the fracture pressure, you do a fracture jobs. But if your pressure doesn't exceed the fracture pressure, you do a matrix. If you mistake in calculating the pressure or pumping pressure, you do a bad acidizing jobs. You know, suppose that you want to do a matrix acidizing, but you don't know about the fracture pressure, and you pump it, you pump the acid into a formation above the fracture pressure. It's lead that you fracture your formation, and it's not a good fracture pressure. It's not a good fracture in the formations, okay? And what is an acid wash that every time we use? And every time after that, the well is the well operation is okay. Check that. Check the formation damages, or if you have a mud filtrate or some things in a well, or for well bore cleaning, we use the acid wash. We injected the acid into a well. We have three type, one of them is that as quickly we clean up the acid. Another one with some additive add to acid. We inject the acid into a well, and for a few minutes we waited to see the effect of the acid, and after that we clean. And another one is that we injected the acid below the fracture pressure and only for the cleaning, and we need the reaction, we need the time. Okay, as you can see here, the acid can spot the process perforation to short soaking period, or and another one, the pressure is applied against the perforation without exceeding the bottom hole fracture pressure. And another one, we can soak it for some minute. Guys, soak or pickling or something that you can every time. Maybe some stimulation engineer used, but pickling is are every time used for the pre-flashes that I will explain it in some next slides. But soak is for the acid wash. Okay. Another one is the fracture acidizing. Is a fracture. What is a fracture acidizing? Again and again. In this webinar, every time maybe I tell you about the fracture of matrix every time. Because these are too important. These are important for us to know it better, because the fracture pressure for us is so important for us. Okay. So again, what is a fracture acidizing? Fracture acidizing is an injection of acid down to the well at a rate faster than the formation can accept it. It means that you exceed the fracture pressure, okay, and your rate must be so much at a higher rate, okay, by the way of natural flow channels. Since the rock will not accept the acid, pressure build-up, and finally the rock ruptures and the acid injection down the fracture within the carbonate formation. We use every time fracture acidizing in a carbonate formations. Okay, remember, fracture acidizing every time used in a carbonate formations. Okay, so low permeability carbonate formation are best candidates for fracture acidizing. And one says, I think that you are here about the fracturing and the fracture acidizing. We have, hydraulic fracturing is different from the fracture acidizing. Fracture acidizing, we use the acid to open or create some fractures by dissolving something or fracture in a formation, in a carbonate formation. But hydraulic fracturing, it means that we injected some special additive, maybe on fresh water. It's not important. With some propant that we use to inject in a well. Why propant? We send a propant, or we use a propant to go to open the fracture that we opened it before by exceeding the fracture pressure by injection the fluid in our well. Okay. Some parameter, if we want to design a fracture acidizing jobs, some parameter is important for us, as like as the rock properties, because we should know about the element of the formation, as like as the limestone or carbonate or dolomite or silt or sand or anything. And again, about the type of the acid that we use. Because of the fracture acidizing, every time we use in carbonate formations, you know, we can use it to some not famous formation, but every time we use it in a carbonate formations, and our acid maybe is the HCl acid, okay? And another one is the contact time. It and the contact time. And some parameter is important for us to create the fracture in our formation, about the geometry of the fracture. Which of them are important? Injection rate, fluid viscosity, fluid volume injected, fluid loss, rock properties, formations, fluids, formation stresses, and the reaction rates. Guys, again, I emphasize on the reaction. Every time a simulation engineer should know about the reaction rate or reaction product of the acid with the formation or some element in a formations, okay? Again, just only I want to talk about with the star title about the hydraulic fracturing. I told before that the hydraulic fracturing is different from the fracture acidizing. The hydraulic fracturing is a process of creating a fracture by injection of a fluid into a formation at a pressure higher than the partial pressure of the formations. And normally, propan are injected with the fluid to probe the fracture open in sandstones. Formation and acid are used to etch the fracture faces, making them uneven to prevent from the completely closing carbonate formations. You know, here you can see the different, some difference between the acid fracturing, abrupt fracturing, or fracturing. In a carbon acid fracturing, we use it in a carbonate formation, but don't sandstone. We use it acid for etching, but in a sandstone, we use it propan. Or as you can see again and again, corrosion and maybe in a hydraulic fracturing fluid, not corrosion, okay? And you can see here, I don't know, you can see my mouse here. If you see that, the blue one, the blue line here is for the natural fracture. You can see. But the orange one or the yellow one is the for hydraulic fracturing. And the red one is for the acid fracturing. If you see that, the faces of the acid fracturing, you can see that you can see the dissolving power of the acid and the effect of the acid on the face of the formation or a stone, okay? And remember it for yourself. Low permeability sandstone reservoir is good for the hydraulic fracturing. And the high permeability carbonate reservoir is good for the matrix acidizing. And the low permeability carbonate reservoir is good for the acid fracturing, okay? That we learn it now. Hydraulic fracturing is good for the sandstone reservoir, and the matrix is good for the high permeability carbonate, and the low permeability carbonate we need to acid fracturing. What is a matrix stimulation? Matrix stimulation is a treatment that we want to increase the well productivity by pumping a special formulated treatment fluid. Okay, it means that in a well, and maybe we have some formation damages. As you can see in a picture, maybe we have a formation damage as a scale. So when we have a scale, we should use a scale inhibitor. Okay, and when we have plugging the pore spaces, we use acid to clean them, to remove them. Okay, so matrix stimulation is different from the matrix acidizing. Okay, in a matrix stimulation, we use a special fluid inject well to cure the well. Okay, but in a matrix acidizing, we use the acid with some special additive, into a well to remove the plugging pore spaces. It means that lead to increase the damage zone of the formations. Okay, so matrix stimulation or matrix acidizing now is used for the carbonate, high permeability carbonate. Okay, and absolutely used for the sandstone formations. But remember, this is important that I want to tell you. A skin factor in a sandstone reservoir, when we use matrix acidizing and inject the acid into a well, our skin factor maximum decrease to 0. Okay, it means that it again come back to its production in past. Okay, but in a carbonate formations, because we create new unimpaired flow channels between the wellbore, our skin factor will decrease to some -5 or 6. Okay, it means that our well now in improvement. So acidizing in a carbonate formation is more and more important than the sandstone formation. Sandstone formation are important, but the carbonate formations, if we do acidizing jobs, we improve the productions. Okay, but in a sandstone formation, we come back again to our last production. Okay. Yeah. Every time I told before, we have two famous formations. Okay, sandstone and the carbonate. Okay, in a sandstone, we have a sand, silt, but we have a cementing bond as the limestone. Okay, and in a carbonate formation, we have the limestone, we have a dolomite, and everything. As you can see here, this is a normal text that maybe some guys told you before, that typically the lower permeability limit for matrix production is about the 10 millidarcy for an oil well or 1 millidarcy for a gas well. Guys, one thing, this is my experience. Acidizing in an oil well is more difficult than the gas well. Okay, if you are a simulation engineer, so you know, but if you want to be a simulation engineer, every time remember with yourself, this is important. This about again a definition about the matrix acidizing, about the carbonate formation. Since the flow channels and the pores in a carbonate are acid soluble because of, if you remember it, some slides at the first time about the reaction, and the product of the reaction of HCl and the limestone and the dolomite. Again, our acid soluble permeability can increase significantly in the part of the formation that the acid contacts. Okay, so we can improve the production. It means that it can improve the production. As a result, we can see the negative scheme factor. Yes, I told before, in a carbonate formation, absolutely, our scheme factor, if our oxidizing jobs is good, absolutely we can get the negative scheme factor. Okay, but in a sandstone formations, after matrix acidizing, where we do an effective treatment result, but our scheme is 0. Okay, so acid can create line dominant wormholes in carbonate, but it cannot create a wormholes in a sandstone. Just to solve some soluble elements that plug in the pore space. Okay. We have some matrix acidizing types: WCO, MWS, or near wellbore stimulations, or IMS, or EMA. You know, guys, if you category the matrix acidizing to four type of them, WCO as like as the acid wash or soaking agitation is not different so much, okay? But the MWS, or the near wellbore stimulation, you create the 2 or 3 foot radius of damage zone, and the ranges of the acid that we use is about the 25 to 50 GPF, or gallon per foot. Okay, and the skin effect on the skin is about the 0 to -2, and for IMS is for the radius is about the 3 to 6 foot, and another one, the volume ranges is about the 50 to 150, and the more important, all of them, is the most important is the EMA. EMA, our radius of our treatment is above the 6 foot. Okay, and the range of the volume that we use is the 150 to 200 to 500 GPF. An effect on a scheme factor, it's about to -3 to -5. Guys, the EMA treatment result in production improvement comparable with the hydraulic fracturing in sandstone. Okay, remember for yourself. EMA, we can compare it with the hydraulic fracturing. Okay. As you can see here, if our skin increase, our production rate will decrease. Okay, and the maximum minus in a skin that we can result in our acidizing, here in a table we see a -5, but maybe -5 to -6, and absolutely it occur in a carbonate formations. And matrix acidizing is sandstone. If you remember, we use HCl acid for the carbonate formations. But in a sandstone formations, we use the mixture of the HCl and HF acid. Okay, and one of the important things that we should do it in our laboratory, it is that we should optimize the mixture of the HCl and HF acid. Okay, if you see that in a table, we have some mixture, 6% of HCl and 0.5 HF, and some mixture strengths that you have that you can see in a table. And one of the important parameters that help us to find the best mixture of the HCl and HF acid is the temperature. Okay, if our temperature has a marked effect on the reaction rate of the hydrofluoric acid with the sand and clay. If you see that our maximum strength HCl in acid is 15% and 10% and 7.5%. In a sandstone formations, we have in sandstone formations, acidizing is good. Okay, we open or we remove some pore plugs in a porous spaces. Okay, but acid maybe solve more element, more sand or silice or anything or clay or anything. Okay, if we our solve element in our acid is so much in a sandstone formations and in a well, it lead to we have a sand productions, and this is a bad formation damages. This is a bad not formation. This is a bad occurrence in the production. Sand production is not good. Okay, if we use not appropriate concentration of HF acid, maybe lead to sand production. Okay, so we can check the slides. Removal of the clays can lead to large increase in improvement rate. Removal of silica coating, allowing the solution of the carbonate deposit, increasing the formation solubility, because the acid remove the some elemented or cementing bond that contain the limestone and remove it on, and we can increase our permeability. And another one, the overall effect of these two actions is significant increase in reservoir productivity, and the use of high concentration of HF acid cause sand productions. As you can see here, some effect of the mixture of the HCl acid with the HF acid. You can see that which of them is the best mixture, and here you can see that how much gallon per foot we need to acidizing per square foot in a pay zone. In a carbonate formations, again in the carbonate formations for the matrix acidizing or acidizing, our main acid is the HCl acid. Okay, and as you can know before, I think much of the world oil and gas comes from the limestone and dolomite formations. Okay, either in their relatively pure form in the form of the carbonate or silica sand cemented together with calcareous materials. Okay, Carbonate matrix acidizing is a well stimulation technique where acid inject at a less than the formation fracture pressure. Okay, remember again, the acid pumping pressure doesn't exceed the fracture pressure to bypass the damage zones around the wellbore. For again carbonate formations, we use the HCl acid. We use the organic acids such as a formic or acetic, and we use some concentration 5, 10, 50 or 28, depend on circumstances. And the acid ranges volume is about the 10 to 200 GPF. Yeah, this is a normally, but when we want to do EMA acidizing, maybe it's about this 100 to 500 GPF. Okay. Guys, now we are in a 40 number in a slide. Okay, let's take a break for yourself. If you have a question now, please write it in a comment zone. If I know the answer, I will answer to you only just for 2 minutes, and again I will continue the webinar with some slides. So, 2 questions I see. Can you give some information about the open or completable simulation and the case for? Guys, what is about the completed, about the completion, case hole or open hole? For acidizing, it's not has a difference, okay? When we want to do a matrix acidizing, just maybe change it for additive, nothing more, okay? Because when we have an open hole, we use some additive for silt suspending or anything to only the suspending the some element that in an acidizing product, and after that we clean it up, okay? And another thing is for when and where we use an organic acid. Guys, we use organic in acid. If you remember it before, I told before, organic acid react slower than the mineral acid, okay? But as like as the acetic acid, organic acid we can use, or formic acid, we can use it for as like as the additive in our acidizing. Acetic acid is for the iron controlling, and the formic acid is for one of the base of our one of the base of the acid corrosion inhibitor intensifier, and every time use it in for controlling the corrosion, okay? And another question is nothing. If we don't have any question, we continue our webinar. So matrix acidizing carbonate. You know, in a carbonate or in an acidizing, we in a acidizing, when we want to acidizing all interval of the well, we should use some type of the acid to acidize all interval. So for effective matrix acidizing of the carbonate reservoir, we use the emulsified acid system, and another one, we use the gel acid system. Okay, why? Because we want to provide the retardation, because we want to achieve the deep penetration, because uh, they're compatible at a high reservoir temperature. Okay, you know, the HCl acid, uh, uh, when we use it or when we inject it into a well, the acid wants to go the first hole that created or before in a well, and again go inside. This is the experimental or the laboratory. If you do it with the core flooding, core acidizing flooding, you can see it. Okay, so because of this one, we use some systems, like as emulsified acid or gel acid system, to cover all interval of the well. In a vertical well, we can ball heading in our well, and again as like as the acid wash, and again after soaking some minutes, we clean up it before, and we clean it up. But in a horizontal well, let's explain about the horizontal well. What is the horizontal well? Horizontal well are normally targeted for steam formations with a good vertical permeability and reservoir that suffer from the coning problems. Okay, as you can see in a picture, why we use the why we drilling the horizontal well. I think that you know it better than me, but in acidizing, in horizontal well is more important than the vertical well. In a horizontal well, all aspects of design in a vertical well, we should consider it in a horizontal well. But we cannot ballhead the acid into a well as like as the vertical well. Okay, in most cases, the acid has a tendency to enter the formation in a zone close to a vertical section, obtaining only partial stimulation. And to overcome this problem, use a diversion technique. Okay, so ball heading acid into a horizontal well has generally proven to unsuccessful. And one small thing that it's an article study, horizontal wells acidizing indicate that the more horizontal lengths that acidize, the more production is possible. So acidizing 25% of the horizontal length of properly will provide approximately 75% of the production potential. And if all of the length has been acidized properly, this important result become a 75-25 rule. Okay, if we acidize more interval, we can get the best result. Okay, what is a diversion techniques? Diversion techniques, again, acid has a tendency to go inside the permeable zone, and we want to acidize all interval of the formations. Okay, so what we can do, we should use the diversion techniques to cover the first permeable zone and divert the acid to another zone. Okay, so we have some diversion techniques as like as mechanical techniques, mechanical diversion techniques. We can use a coil tubing or packer, chemical as like as bulk sealer particulate, or formed acid and viscous fluid diversions. So what is the diversion techniques in mechanical? If you see that, if we want to acidize the zone B, we should set the packer between the B and C, and our coil or anything, our tools comes to near the packer and a set. And again, we injected the acid inside the coil to just only acidize the zone B. With the packer, in a mechanical system, with a packer, we can acidize a special interval of the formations. Okay. And another one is a ball sealers. Ball sealers are rubber-coated balls that designed to sit in the formation. It means that when when you acidize and open the permeable zones, the ball sealer sit on the permeable zone and divert the acid. Again, goes to inside the well, or divert the acid to next interval. Okay. And another one is you can see the schematic of the ball sealer in a well. The ball sit on the permeable zone and divert the acid to next zone. Another one is a fine as particulate diversion. We use some particulate as the ball. We use it and we send it back, and they sit on the permeable zone, and again divert it to divert acid to another zone. And another one is the foam acid diversion. The foam acid diversion, as if you want to know about the foam acid diversion, we use acid when using foaming diversion techniques. The first stage of the acid solution is injected. Okay, every time we inject the acid at first. But the foam acid again cover the permeable zone and divert the acid to another zone. Okay, you see that as in conventional acidizing jobs. This is followed by an aqueous solution of a foam producing surfactant, which is displaced into a formation with a compressed gas such as a carbon dioxide or nitrogen. Okay, and because of the foaming, the acid reduced the effective amount of acid, so 28% HCl should be used in preparing the foam acid to maximize the amount of the acid volume. If you see, every time the diversion techniques only cover the permeable zone and divert the acid to another zone. Another thing is that the viscous fluid diversion. What is a viscous fluid diversion? The viscous fluid diversion in a marketing, we have some viscous fluid diversion. Here, just only I want to talk about the VCA and VDA. The VCA is for the Halliburton that you can see here in the picture as a gel and polymer. And as you can see here that the first stage main acid go, and the polymer or the VCA cover the first zone, permeable zone, and divert the acid to another zone. And another one is the VDA. And the marketing and the industry now use the VDA system, or VDA is a diverting acid or a self-diverting polymer-free acidizing fluid, can be used alone or with treating acid to maximize zonal coverage in carbonate reservoirs. I told before, if we acidize total interval of the well, we do our best jobs. Okay, we do the best acidizing. And some advantage that VDA it has that improve the zonal coverage. Okay, efficient wormholing behavior in a wide range of the conditions. Yes, better leak of control, high fluid efficiency during acid fracture treatment, and a simple mixing for a smaller equipment footprint. As you can see here, the VDA at first the live VES, you can see that. Another water, the spent acid, it means that the VDA reacts by the limestone, and after that we cannot put the acid inside the well. We should clean out of the well, and we should break the spent acid, the VDA. When we want to break the VDA, we use some mutual solvent to break the VDA, because we don't want to put a residue in our well. And you can see here, this is the skin factor formula. When we use the VDA system, we can use it. And we can calculate it, skin factor by the VDA and the radius of the VDA invaded in a well. Okay, this is as the Hawkins formula. So what is the viscosity? Viscosity is defined as a property of a fluid that resists a force tending to cause the fluid to flow. The viscosity of the water is 1 centipose, and the viscosity of the HCl 28% is about the 1.8 centipose. I told it before that some slide that we start, just for your information. I told it before because we should know about the viscosity and the non-Newtonian or Newtonian fluid, because when we want to calculate the rate of the pumping, or calculate the pumping pressure, we need all of them in parameter. And you can see that the Newtonian fluid, when Newton fluid, every time, if you see that undergoes continuous deformation when subjected to shear stress, such as when it's pumped. Some fluids follow a standard pattern of the behavior under shear stress. If you see that the shear stress, when we have a normal flow or turbulent flow, every time follow a standard pattern. Okay, and again, you can, if you want to know about one famous is water, or most oil or liquid are then Newtonian fluid, and another one is a non-Newtonian fluid. It means that doesn't follow the shear stress pattern, because as the VDA. Okay, VDA is a non-Newtonian fluid. Okay, and in a pumping, we should consider about the flow. We should consider about the rate and the pumping. Till now, just we talk about the benefit of the acidizing. Okay, so we told that. I told before, acidizing help us to cure the formation damages, to remove the formation damages, to increase the permeability and other. But some formation damages caused by matrix, as like at the consolidation of the rock matrix, generation of migrating, secondary precipitation, water blankets, fluid incompatibility, acid precipitations, wettability changes. Okay, these are our formation damages caused by matrix. How we can control these formation damages? By a special additive that we use. Okay, so what is an acid additive? We have some famous acid additive as like as the corrosion, surfactant, nanoemulsifier, anti-sludge, iron control, mutual solvent, friction reducer, clay stabilizer, and diverting agent as like as the VDA and alcohol. Okay, so let's briefly explain about the corrosion inhibitor. Corrosion inhibitor just for our equipment and just for the prevent of the corrosion during the acid jobs. One of the most important additive we use in acidizing is surfactant. Surfactant can change the surface and interfacial tensions, and one of so important surfactant are the best additive that we use in acidizing, because whenever we want to clean up the well, it help us to clean up the well as soon as we can. Okay, and another one is a non-emulsifier. It means that when the acid tend to be emulsifier, we add in a line interval well, we use a non-emulsifier in a short interval when we use a non-emulsifier to prevent the tendency of the acid to be emulsified. Okay. And another one is the anti-sludge. If you anti-sludge, 90% used in oil well, not for gas well. And another one, the clay stabilizer. If you see that clay stabilizer, because we have some clay in acidizing, maybe effect on our acidizing as like as elite or cal unit or multiple unit, and we use a clay stabilizer to control it. And another one is a diverting agent. As in a marketing, we have some diverting agent as like as a VDA or STA or a VCA, and some type of the we have in a marketing. Another one, the mutual solvent, that this is the as like as a spanner in oil industry, as and this is as like as a surfactant to maintain waterbed formations to waterbed insoluble formations, and one of the most important performance is that to reduce the water saturation near the wellbone. And another important one is the iron controller. What is the iron controller? You know, one is the one of the bad formation damages caused by acidizing is secondary precipitation. You know, when we do acidizing job, the iron the iron ion will release, and when they release, they want to sit on a permeable zone. After they sit the permeable zone, and we don't clean up the well as soon as we can, the iron control flag the pore, and it leads that our acidizing jobs is not good. So the cleanup is more important, and the iron control additive, and choose the iron control additive is more important. Iron control, how we, when appreciable quantity of iron in the form of the ferric ions rather than the unusual ferrous ions are dissolved by the acid, iron precipitation and permeability reduction can occur after acidizing. How we can control it? With the pH control acid, with the pH controller, somebody asked me, when we use the organic acid, yes, acetic acid, you can see that for the pH control sequestering agent as like an EDTA or NTA or citric acid, and another one is the reducing agent. It means that converting the ferrous to ferric to ferrous ion. You can see the table here. We got some type of the iron control additive that use it in a acidizing with the economical parameter, with effective of the formation, with the client asking, we choose it for our acidizing. But the famous one is the EDT or NTA or acetic acid. Another additive that we use it in acidizing is alcohol. Alcohol is preventing from the water blocking and enhancing the fluid recovery, retarded acid react, and decrease the water content. And two famous as alcohol that we use it in acidizing is methanol and isopropanol. Okay, and it has some advantages if we use it more dosage that we want to in acidizing. Yeah, the more important the more important disadvantages is the effect is the increase in corrosiveness and some parameter. When we want to use the acid additive, we should check some consideration about the compatibility, about the solubility, about the dispersibility. Why compatibility? Because when we use some additive from some company, okay, we should check it with our acid, because maybe this additive doesn't compatible with our another additive. But this compatibility means for the formation, because some additive is not compatible with our formations or with our systems or with our equipment. And another one is the solubility. If you can see that. Another one is dispersibility. If an oil soluble additive is to be used, a dispersant must be added to the acid system. A good example of this is xylene is acid. Here I want to start about the matrix acidizing design procedure. This is my lovely part of the webinar that I want to introduce you, but only for some slides, because each parameter here has a word for itself. And if I have a time, maybe I do a webinar for advanced acidizing about the calculated pressure or rate or anything. In a matrix acidizing design, we should consider some parameter: formation properties, deviation about the type of the well, open or case hole, perforation interval, reservoir fracture gradient, and other parameter that we use. You can see here, step 1, we should use a data form for ourselves. We should know about the data that in acidizing we use: the formation reactor, reservoir temperature, thickness of the pay zone, drainage radius, permeability, porosity, wettability, all of them. Okay, after we gather all of them, we go to next step. Okay, now we want to acid, for example, we want to acidizing a sandstone formation or mud or carbonate formation. So we send our data, or we send a code to our laboratory, and we check it with our laboratory. Guys, please check it: compatibility test, corrosion test, iron control test, emulsion test, and the diversion performance, because we have some diversion additive in marketing, and we should choose the best additive. Every time when we have a diversion additive, we should check all of them and check it together, because it's important for us, and it's important for us to choose a VDA that it has a performance on a high temperature. Okay, maybe maybe every time our temperature, maybe we have an additive and VD additive that I see it in a marketing. Unfortunately, just good for the low temperature reservoir, not for high temperature. Okay, every time we should check it with our laboratory. Another step is to calculate the volume of the acid. to calculate volume of the acid. If you remember it before, I told before that the reaction rate, the reaction product are important for us. The stoichiometry number, the gravimetric or volumetric dissolving power is important for us to calculate the volume of the acid that we want to inject into a well. And another one is to calculate the pumping pressure. Okay, how we can calculate the pumping pressure? We should know about the surface injection. We should know about the flowing bottom wall pressure, hydrostatic pressure, frictional pressure drops. And every time when we want to check the pumping pressure in a when we want to use a pumping pressure in operational, we use a safety margin, or we minus 5% of the 5% of the result of the pressure. The friction pressure is important parameter for us because it maybe change our pumping pressure. If we don't know about the friction pressure, our pumping pressure may be changed, and it's not good for us. About the FP, fracture pressure, we should know about the fracture pressure, and we don't want to exceed the fracture pressure when we want to a matrix or fracture. Here, another step is the pumping rate calculation. Pumping rate calculation, it depends on, again, the volume, again, on a pressure, again, on a viscosity, again, on a radius of the damage, again, on a total and other parameter that you can see here. And step 6 is we should use we should gather all data together, and after that we should plan it together. Plan it normally. In acidizing, normally we use a pre-flush for step 1, and after that the main acid, and another one for diversion. If you remember it before, diversion, because with a diversion we cover the permeable zone and divert the acid to another zone. So the total interval we divided to some interval to and we use a diversion to acidize total interval. And after the finished acidizing, we use the overflushes. And after overflushes, we use the displacement. And just only for the theoretical, I will tell you about the pre-flushes and overflushes. What is an pre-flushes? Pre-flushes is the one step for acidizing. You know, we want to prepare the formations for the main acidizing. You know, we can use the acid we can use the acid we can use the acid type of the pre-flush, and we can use the non-acid type the pre-flush. Okay, it depends on you and your formation and your client ask you, and anything that you think it's good for you. You know, if your pre-flushes are often used ahead of an acid treating solution to prepare or condition the formation so that it will accept the acid in the most favorable section and without creating the damage. These pre-flushes the perfluxes allows the formation to react with the acid in the oil-producing interval whilst restricting the invasion of acid into a water-producing stratum. So every time in acidizing, we use the step 1 for the pre-flushing. You remember it, not this text, only this parameter, okay? This as sentences I tell you now. Only for preparing for or pickling the formation or prepare the formation for the main acid. Okay. After that, we used other some about the pre-flush, overflush. What is an overflush? Overflush is the displacement of the acid creating a solution with more than the volume of the fluid required to clear the tubing and the casing. Okay, now overflush. I usually use a surfactant in an overflush because whenever I want to clean up my well, I should have a more surfactant in my overflush to to decrease in cleanup time. Okay, the cleanup time is important for us. Okay, if you when using retarded acid system, the reaction time can be longer than the injection time. Greater penetration may be obtained by over displacing the acid. The exact amount of overflush used is related to the reaction time of the acid. Therefore, for the maximum penetration, just enough overflush should be used to keep the acid moving within the formation until it's spent. And step 7 is simulation. What is the simulation? You all gather all data. Okay, so put together, design a plan. So if you are a simulation engineer, you want to know about your future result with whenever you have all data. You know, the simulation just convince you and your client, but every time maybe change your program or change your result in acidizing. But simulation is approximately near to your result. And successful matrix acidizing jobs when we know about our shutting time. You know, shutting time is that after acidizing jobs, the well in a carbonate formation absolutely should open the well or clean up the well immediately after the acid job finish. But in a sandstone formation, you can wait it for some minutes. But the shutting time in a carbonate formation is 0. Okay, and we should know about this one. And after acid jobs, you do your acid jobs well, but the acid jobs when the result is when the production rate increase, you can see your acid jobs. It needs that the professional chokeman or a completion engineer that knows about the acidizing job procedure. And a shutting time mean I told you before. And the acid job evaluation, you can acid jobs, and you can see the acid jobs rate and pumping pressure, and I say in a real data time, and you can collect all, you can collect and analyze spent acid returns in a cleanup procedure, and you can compare your graph in productivity improvement with the productivity potential before by real-time data computer analysis. And some parameter that important to designing acid jobs. When acid jobs do not work, it means that when we don't choose the appropriate rate, appropriate pressure, appropriate volume of the acid or type of the acid, or not good fresh water, or expired additive, as some things that maybe occur and change our acid jobs do not work. And this is the my last part of our webinar. This is the deep culinary stimulation vessel. This is this stimulation vessel that I have been working on it from since 2040 2014. And the step, you can see that every time we do engineering design procedure, load acid and additive, safety meeting, rig up, pressure test, pumping, secure the value, cleanup operation, and the secure the value. You can see that here the schedule of the pumping. You can see here, and you can see here the loading additive approaching to platform by DP mode, and these are the high pressure equipment. And here our control room, our operator sit here to manage the mixing of the acid and additive to pumping in a well. And the cleanup procedure, here is our choke. And here are my references. And thanks a lot for your attending my webinar. And if you have a question, if I know the question, I will answer to you. Thanks for your taking your time. Somebody told me that one of the acid operation that I attended, we injected diesel before the acid because of the paraffin concentration in the formation, but it didn't work. So my question is, injecting heated diesel can provide better simulation. Do you have any idea? Yes. If you use it, the diesel with a xylene or some surfactant, maybe your result will be better. How to access your note? Okay, you can send an email to me and I will send a file to you. Are there conditions that will require you to use specifically either emulsifier or gel assistant individually? You know, it depends on the formations and your permeable zone. And if you have a like formations about the properties and about the properties, you can choose it better. Okay, but the emulsified acid, you can use a diesel with or oil base, but in a gel acid, you use a polymer type of additive. You can gel the acid and divert. But for my opinion, emulsified acid is better because gel acid, if you cannot break the gel, maybe it has a residue and it's not good for the well and the cleanup is not good. Thank you so much. If no more